Good morning, students. Today we will start with the topic on engineering curves, which comprises of the curves such as cycloid, involute, and helix. So let us move forward with the first question of cycloid, which says a circle of 70 mm diameter rolls along a straight line without slipping. Draw the locus of point P on the circumference of the circle for one complete revolution. Name the curve. Draw a tangent and normal to the curve at a point on it 70 mm above the line. So the important data which is given to us in the question, I will highlight that. It is a circle of 70 mm diameter. Then it is rolling along a straight line without slipping. And what we have to do is draw the locus of point P on the circumference of the circle. This statement, point P on the circumference of the circle, gives us the hint that we have to draw cycloid and not the involute. In exam, we have seen that in the question it is asked to draw cycloid, students make involute, or it is asked to make an involute, students draw cycloid. So this is the point, or this is the statement which will confirm you what you have to draw. You have to draw either a cycloid or an involute. So this particular sentence which I just highlighted, we have to draw the locus of point P on the circumference of the circle when it is rolling. That means we have to draw the cycloid. So here it is written, name the curve. So after drawing, you have to just name the curve as cycloid. So moving on to the construction part. So it was given that we have to draw a cycloid of a circle which has 70 mm diameter. So first of all, I will construct a circle of 70 mm diameter. So radius is given as 70. Sorry, radius is given as 35 because diameter is 70. So I am just taking as 3.5 as radius, and I will make a circle. Now, after doing this, we have to divide the circle into equal parts. Now, equal parts can be 8, it can be 12, it can be 16, it can be 4, anything. But as we increase the number of parts, the construction also increases. On the other hand, if we decrease the part, we will not get the actual or smooth curve. So just to maintain the balance between the construction part and the smoothness of the curve, let us now tell that we will stick to around 8 parts, or dividing the circle into 8 parts. For dividing the circle into 8 parts, we'll make a diameter line. And this all construction should be very light. So whatever I will draw in yellow, it should be very light part. So by doing this, I have divided into 4 parts. Now for 8 parts, we have to make a use of protractor. Keep it here and mark 45 degrees. So just marking 45 degrees at this particular point and this particular point from this side. If I measure, it will come around here. Now, after marking 45 degrees, we have to just connect these lines. So I will connect this dot with this particular center. Again, the things should be very light. And similarly, I will connect this 45 again with the center and extend it towards the other side. This will give me the 8 parts of the circle. Again, I repeat, this all things should be very, very light. Now we have to make a horizontal floor on which it will roll. So the length of the horizontal floor which we'll make will be equal to the circumference of the circle. Again, I repeat, once we have made this circle, we have to roll it on a horizontal plane for one complete revolution. And one complete revolution means the length of the floor will be the circumference of the circle. So you have to calculate the circumference by the formula 2 multiplied by pi, that is 3.14, multiplied by r, which is 35 in this case. So we are getting answer as 219.8 mm. So 219.8 mm means 21.9 centimeter. So what you need to do is take the scale now and just mark from this point. From the point which is touching the ground, we have to mark the circumference which we just calculated, 21.9. So we have to measure our line. Again, it should be very light, 21.98. So approximately here, 10. Next part is divide this line, divide this line into same number of parts as that we have divided in the circle. So our circle we have divided into 8 parts. So this line will be also divided into 8 equal parts. So for that, a very simple construction technique, I can say, what you have to do is you have to keep this scale here and measure any random angle, most probably less than 30 or around 30 degree of any length. Then by using compass, again you can take any radius, or if you don't want to use compass, what you can do is on the same line you mark 1 centimeters. On the same line you mark 1 centimeters. So let us say I am here. So 1, then sorry, then 2, 3, 4, 5, then 6, 7, and 8. So because I have divided a circle into 8 equal parts, I am dividing this line also into 8 equal parts by using, let us say, 1 centimeter distance. Now what you need to do is you need to connect this last point with the last point of your perimeter. This was the last point of our floor. So we have to connect this last point with the last point of this. So I'm using again yellow color. That means it should be very light. So I have connected this part. Then using parallel lines by means of roller scale, what you need to do is you just need to make parallel lines from all the points which we have just made. So I'm just moving this part now, moving the scale to this part and make a parallel line. You use roller scale or drafter for this. Then again, I will move. The same process has to be done for all the points. Now, once this is done, we will now start naming the points. Now, again, an important part. If you do the naming wrong, the entire involute or cycloid may come wrong. So let us start with the point which is given in the question. So it is given in the question that you have to trace the locus of point P on the circumference of the circle. But where is that point P is not mentioned in the question. So we can assume it wherever we want on the circumference of the circle. So let us say I will assume that point P is this side. So as per my assumption, let us consider point P on the bottom point of the circle. Now, once this point P is selected, we have to start the naming in the clockwise direction because this circle is moving in clockwise. So this point will become point number 1. This will be named as point number 2. Then this will be point number 3, point number 4, point number 5, 6, 7, and last point is P, or you can name it as 8. Now, the same numbers to be given on this particular parts also. So this particular first section will be termed as 1. Then this will be termed as 2. Then this point is 3, 4, 5, 6, 7, and 8. So now the circle and the line are divided into 8 equal parts. Now what you have to do is from all the points on the circle, again I repeat, from all the points on the circle, draw horizontal lines. Again I repeat, the construction should be very light. Draw horizontal lines from all the points on the circle. Should be perfect horizontal lines. So if your construction is perfect, the point 3 and 5 will come on the same projection lines. So basically these are known as projection lines, which I am making now. Then 2 to 6. Then from 1, if your construction is perfect again, 1 and 7 will lie on the same line. And last is 8, which is already made. Now, as we have drawn horizontal line from all the points on the circle, we have to make vertical lines from all the points on this particular line. So starting with point number 8, again, it should be very light. So I will draw vertical lines from all the points on. Now, wherever these projectors intersect, we will name that points as C1, C2, C3, and so on. So let us say this is the center, the original center. Then this projector 1, from the projector 1, this line and this C, wherever they intersect, that will be termed as, let us say, center C1. Similarly, this will be termed as C2. Then this will be termed as C3, and so on. Note that dimensions and this particular namings should be given in the medium dark lines. So yellow ones are the lightest possible lines. This numbering will be in the medium part, and the involute or the cycloid which we will draw, that will be the darkest. Now, next point. Take the compass of the same radius and measure the same radius of as that of the circle, that is 35. So I will also measure 35 here now again. Now, what you do, what you have to do is we have to keep this compass on C1 as center and cut an arc on the line of projector 1 from the circle. Again, I repeat, you have to keep your compass on center 1, that is center as center 1, and cut an arc on the line extending from 1. So I will do that now. Similarly, we have to shift our center to point number 2, maintaining the same radius. And then we have to cut this arc on projector of line 2. So this is point number 2. The projector is this one on a horizontal line. So we have to cut the arc on a horizontal line for the same. So on this line, we have to cut the arc. So I will cut here. So this is the arc cut on horizontal line of 2. Then shifting our center to point 3. Then from point 3, where we will cut on the line 3 on the horizontal line. So this is the horizontal projector of point 3. So on this point, on this line, we will cut an arc, naming it as P3. Then shifting our center to point number 4, cutting will be done with the same radius on the projector of 4. So just see. Now again, if your construction is perfect, this point 4 will exactly touch at the top of this particular line. This arc will be becoming a tangent to this line. Now going to point 5, shifting the things to point 5. Then cutting will be done on the line coming from point 5. So this is the point 5. The line is this one. So we will cut on this particular part. So this is the cutting done on 0.5. Then shifting the center on 0.6. We will cut on the projector of 0.6. 0.6 is here. So this is the projector. So I will cut on this particular horizontal line. So this is 0.6. Then shifting the center to point number 7 and cutting on the projector of 7. So 0.7 is this. So this is the horizontal projector. So making a cut or an arc at this particular point. And then finally, I will shift the radius to zero point 0.8 or center to C8. And if your construction is perfect, then this will exactly cut at this particular. That means the arc will be tangent to the point or to that line on 8. So this is the particular point. Now, at last, what we need to do is we have to make a smooth curve passing through all these particular points, and that curve should be the dark curve because like this. So I hope that there is no doubt in drawing the cycloid now. Now, regarding the tangent and normal to the curve. So in the question, it is mentioned that you have to draw normal and tangent to the curve at the point 70 mm above the line. So what I will do is I will keep a scale like this, vertical, and I will just measure wherever this 70 comes. So here it is only 40, here it is only 55 if you see, here it is 65 around, then at I am getting 70, perfect one. So that means I need to draw normal and tangent to this particular point. It will become very easy. So let us say I am taking that, I am changing the question that draw a normal and tangent to the curve at a point 50 mm, 50 mm from the base or 50 mm above the line. So if I want to measure 50, it will come somewhere here. Okay. You can see there is a distance of 5 centimeter from this baseline. I will just mark that point here. So this is the point on which I need to make the tangent and normal. Now the process. What you need to do is keeping the same radius, that is 3.5, keep on this particular point and mark an arc on a center line. You have to cut an arc of same radius, that is 35 mm, on the center line. Now, wherever it touches the center line or wherever it cuts at the center line, you have to draw one vertical line at the extending from this point to the bottom. Again, this all will be a very light lines because they are the construction lines. Wherever this line, wherever this vertical line cuts the horizontal line or the baseline, join this point with the point on which we want to make the normal and tangent. So this was the point here. Again, this will be dark because this is the actual normal which we are making. So the point which comes down, this point, and the point at which we have to draw the normal, this point should be connected. So this is nothing but your normal. So I will name this as N and N again. So this is the normal to the curve. And regarding tangent, we know the property that normal and tangent are always perpendicular. So what I will do is I will take the protector, orient it with this line, and we'll just mark 90 degrees. somewhere. And now I will join these 2 points, the point which I just marked and the point from which we want the tangent and normal. And I will name this as T, that is tangent. Tangent. So this completes the numerical of drawing a cycloid of diameter 70 mm, which is rolling on a surface in the horizontal direction. Now, there might be confusion. If you might have observed very carefully, from points C1, C2, C3, and C4, when I was cutting the arc, I was going in the left side. I was making the marking or cutting on the left side. Whereas when I shifted from C4 to C5, C5, C6, C7, and C8, I make the cuttings on the right side. So for that, I will give you a simple rule that if point P is making an upward movement, if point P is making an upward movement, can make the markings on the left side. And when point P starts moving down, then make the cuts on the right side. So if you observe here in this diagram, point P started moving from this. That means it is starting moving upward from point 1 to point 2, point 3, point 4. And it was at the topmost position at point 4. So what I did is from point 1, 2, 3, and 4, when I cut the arc, I was cutting it on the left hand side. That means this side. And then when P came here, it started to move downside. And when it is going downside, I started make the cuts on the right side. So from point 5, I made a cut on right side. Point 6, I make a cut on right side, and so on. So this is a trick how to cut a arc on left side or right side. So if point P is moving upside, then cut on the left side. If point P is moving towards downside, then cut on the right hand side. So I hope that there is no doubts on this. Now regarding dimensions, I have not given the dimensions here. So we have to make the dimension also. So for dimensions, the 2 dimensions required are, the first dimension is the dimension of the circle, that is this one. So dimension line should be a light line, sorry, medium line. So just making the dimensions lines. So dimensions also have 1 or 2 marks depending on the weightage of the question. So don't forget to give the dimensions. So 70 mm was the diameter. So marking as 70. And then we have made this part as circumference, that is 2 pi r. So I have to make that dimension also. So dimension for this line. Again, it should be light or medium. Not light, it should be medium because it's a dimension line. This point. And this one. And the value was, I think, 219.8. So I will also write the same thing here, 219.8. So this will be placed exactly at the center. So this completes the question in all respects, wherein we have traced the locus of a point P, which is on the circumference of the circle. And also, one more point is missing here. We were also asking the question to name this curve. So this curve name is cycloid. How this question is complete in all respects. So I hope you have understood the construction part of a cycloid and you don't have any doubts regarding this. So in next class, we will also see one more problem on the cycloid, wherein the point P will be at the top of the circle, and then we will proceed further with the involute part. Thank you.